So we're going to look at these two limits. We'll start with the one on top. Now, if you have a calculator, it's advisable to graph these first, do the tracing, see if you can reason out, what you think the answer is before you attempt any algebra. So let's do that. So we go to our calculator here. I have both functions in the calculator. On a TA84, if you highlight the equals sign and you hit enter, it becomes unbolded, which means it won't graph. On the T89s, if you press F4 while highlighting a graph, it unchecks it, which means it won't graph. So now the second one there is highlighted, and there's the function 5 minus the square root of x divided by x minus 25. So we're going to look at the graph of that thing. But generally, you don't know what window to use to start with. I usually prefer to start with zoom 4, maybe, to see what I think. And I don't see much here. Now, I'm going to have a problem, too. I want to pick numbers that are close to 25, because that's the limit I'm approaching. I'm saying, what happens to the y values of this function as x gets close to 25? So I want to plug in numbers like 24.999 or 25.0001. I want to plug in numbers that are close to 25 on the left side and the right side, but not equal to 25. OK. Well, if we look at our calculator, and I press zoom 4, even if I press zoom 6, zoom standard, which is the same for the T84 and 89, and I press window, the largest x value you have there is 10. So when you want to trace 24.999, the calculator's not going to let you do that because x max can only be 10 in this picture. So you need to change that. So I'm going to go to 30. Now, while I'm at it, I might as well change x min. I'm just going to make that 20 because I really only need to look at this graph between around x equals 25. So I'm just things like that. Now for y min and y max, I don't really know yet. So I'm going to press graph and look at it now. And you'll notice I can barely see anything here. If I press the trace key, which is F3 on the T89, here it is. X equals 25, there's no y value. So first, you shouldn't be surprised by that. Because if we look at the function, if x were equal to 25, it would be undefined. So we're not surprised that when we have 25 typed in, that we get no y value back. All right, let's go back here, though. Let's try those other numbers, like 24.99. And if I do that, I get back this number, negative 0.1000001. And you need to ask yourself what you think that's close to, or what's it getting close to. So to figure it out, I'm going to go 24 point, and I'm going to do 4 nines this time instead of just 3. And I hit enter. And it gets even closer to negative 0.1. So I'm getting to suspect that the limit might be negative 1/10. All right, let's try the other side of 25, like 25.1. I get back negative 0.0999. And that is really close to negative 1/10. Let's try 25.01. And sure enough, that's even closer. At some point, the calculator will start to round. And let's get an extra 0 in there. And it might not even show you anymore. Well, that's really close. So I suspect, or I think, that this limit is equal to negative 1/10. OK? So now, the question is, how do we get that without using a calculator? So that's what we're going to do first. So limit as x goes to 25. Let's remind myself what it was. There it is. OK. 5 minus the square root of x over x minus 25. OK. So obviously the problem is this x minus 25. I need that to cancel somehow. Because if that cancels out of there, then I'll be able to sub 25 in and get an answer. Right? If I plug in 25 right now, which is something I would attempt to do, I would have 25 minus 25 in the denominator, and it won't work. So what I'm going to do is multiply by the conjugate of the numerator. Now, some of you might be thinking, why conjugates? What's so nice about conjugates? So let me just tell you something that reminds you of something that you know about. Early on in your algebra careers, you learn how to factor a squared minus b squared. Right? You have a teacher who might say something like, oh, that's the difference of 2 squares. Maybe you remember it as dots. I don't know, but people do that. And you know that this is always a minus b, a plus b. Okay? So you learn to factor very quickly these kinds of things. So what's a problem usually look like? It usually looks something like this, like x squared minus 9. And you're like, oh, that's easy. It's x plus 3, x minus 3. And you factor it very quickly. Okay? Now, my claim is that you should also be multiplying conjugates very quickly. If you look at these two factors you have here, these factors are conjugates of each other. Look, you have the same numbers, a and b, but one is minus and one is plus. And that's the same thing you have up here. You have the same two numbers. You have 5 and 5, rad x and rad x. One is minus and one is plus. Now here's the beauty of multiplying conjugates, right? When you multiply conjugates, you end up getting the first number squared minus the second number squared, and you get no middle terms. That's why we love conjugates, in case you didn't know. So on the top here, what this becomes is, this becomes the limit as x goes to 25 of the first thing squared, so that's 25, minus the second thing squared. But oh wow, square root of x squared is just x. And on the bottom, some of you might have been scared for a minute saying, oh, I'm going to have to multiply that. Don't bother. Just leave it. You can think about it from this point of view. You know you want to cancel this thing over here. You're looking to get rid of that. So why bother to multiply it into this binomial and make it all messy and then factor it back out? Just leave it. Because now you can clearly see that these two pieces divide out to -1. So our limit now becomes the limit as x goes to 25 of -1 over 5 plus the square root of x. Okay. So it's important to note that this thing came from originally having 5 minus the square root of x over x minus 25. Now, let's be clear about this. These two things, when graphed, will lie right on top of each other. But there is a difference. For this graph right here, x can never equal 25, because you try and plug in 25, you'll get something undefined. So if you think about what we did on our calculator, what we tried to do was we plugged in numbers really close to 25. You can see here like 25.001. Now, it might have been nicer if I could see a little more of this picture. I'm going to fix that now. So I'm going to press Window for a minute. I'm going to go to ymin. And with ymin, I'm going to make that -0.2. And with ymax, I'm just going to make that 0. Okay, so now when I press the graph, you'll be able to see this picture of this function. Okay? And actually, something really nice happened. Calculator doesn't always do this for us unless you have like the perfect window. But if you look at this window, what do you notice? It comes up, and then there's a little gap here. And then it continues. The calculator started telling us, hey, look, there's a hole in the graph, right? Doesn't work. It happens when x equals 25. And we know that because our function is 5 minus the square root of x over x minus 25. Well, you can't plug 25 in there. Because of algebra, we figured out that this thing would have this have the same graph. It was 5 plus the square root of x. But there's a big difference. Because when you get to x equals 25 for this green graph, it'll work. So the green graph goes through the picture like the following. So that's the difference between the two graphs. Now here's the fun part. We're ready to finish. Let's go back to our limit here. If we look at this limit right here, we have the ability to plug 25 in. We can do that because it's in the domain. And if I do that, look what happens. I get -1 over 5 plus the square root of 25. But that's really -1 over 10. Oh, -0.1. So let's go back to that last problem. We'll go back up here, and we'll take a look at this. So here we are. I'd like to be able to do this algebraically. What did you get for an answer, by the way? Turns out to equal -1 over 48. That's what that decimal is that you keep getting. You might not know that, but that's all right. So how do you solve this? It's actually a pretty fun one to do. Generally, what we learned is when we have complex fractions, we multiply everything by the common denominator. So the common denominator here would be, of all three of these, is 2x. So multiply by 2x, 2x, and 2x. Now watch what happens next. On top, you're going to get 2 plus x. Because the x's cancel here and the 2's cancel here. On the bottom, I'm actually going to leave this separate, and I'm going to remember how to factor this. So that factors into a cubed plus b cubed factors into a plus b times a squared plus ab plus b squared. That is a fun fact. I'm sorry, not plus, minus. I made a mistake here. So that's a fun fact. So ready? A in this case is equal to x, and b in this case is equal to 2, because 2 cubed is 8. So here we go. I'll write this in blue here. This is going to be x plus 2 times x squared minus 2x plus 4. Okay, so what happens? Well, the 2 plus x's cancel. And what you get is 1 over 2x times x squared minus 2x plus 4. But now you can actually plug that negative 2 in. Well, let's see what happens. I think it's going to be negative 1 over 48. That's what we said. Okay, fine. Watch this. Ready? 1 over 2 times negative 2, negative 2 squared, minus 2 times negative 2 plus 4. So here we go, kids. Good times. 1 over. This piece right here is negative 4. And in here we get 4, 4, and 4 all added together. So that's 12. Negative 1 over 48.